Now we're going to look at molecular compound nomenclature, and most people find this easier simply because we don't have to worry about all these variations. There's no dealing with polyatomic ions and transition metals. The formula tells us exactly how to name that compound. So first, let's look at some characteristics of molecular compounds. We call these molecular or covalent compounds because they have covalent bonds. They tend to exist as discrete molecules, so we have individual molecules of these compounds, not like we see with ionic compounds where we have these kind of continuous arrays of ions. Molecular compounds are usually composed of only non-metallic elements, so those elements kind of on the right side of the periodic table, and most of them are binary compounds. That means they contain two elements, but they could very easily contain many atoms. Okay, so they can contain many atoms, even if they only contain two different types of elements. And there are exceptions to that, but we're going to mainly worry about the binary compounds. So to name molecular compounds, much like we do with ionic compounds, we name the first element that's written in the formula first, and then the second element. Now, if we write the formula of an ionic compound, we always write the cation then the anion. For molecular compounds, the way the formula is written, the way it's given to you, or the way the name is given to you, tells you the order in which they will be in the formula. We also change the ending to IDE, much like we do for our anions. Even though we're not dealing with cations and anions here, we're talking about molecular compounds that are covalently bonded, and these result from the sharing of electrons, not from the transfer of electrons. So we're talking about sharing electrons, so there are no cations or anions. So I can look at an example here. I've got carbon and oxygen. So there's my formula, and so it gets named carbon monoxide. So that mono prefix tells me that I have one oxygen. Now we only have one carbon. We'll talk about why we don't put any prefix there, but these prefixes tell us the number of each element. So if I look at something like N2O4, I have two nitrogens and four oxygens. So I see nitrogen is written first in my formula. So when I write the name, I'm going to write nitrogen first, but I'm going to use the prefix di to indicate that I have two nitrogens. And in the oxygen, there are four of those, so I'm going to use the prefix tetra to indicate that there are four of those oxygens. So it doesn't really, there's no figuring out what the formula is and worrying about how many nitrogens and oxygens, because we can actually have lots of different combinations of these nonmetals and form lots of different compounds. Even looking at in nitrogen and oxygen, there are several compounds that we can form just from those two elements. So we can't just say nitrogen oxide because that doesn't tell us which specific compound we are talking about. So the prefixes, and these are all listed in your book as well, but we have the prefixes associated with each number. So we have mono, so one, we've heard that before when we talked about monatomic ions, so one atom ions. Di means two, tri means three, so think about your tricycle. Tetra is four. Remember the Tetris game had four little squares in each of those little puzzle pieces. Penta is five. Hexa is six. Hepta is 7. Octa is 8, so we got our nice stop sign going there, so with 8 sides. 9 is nona, and 10 is deca. So you can think about a decade being 10 years. So you do need to know these prefixes and the numbers associated with them because they're a critical part of being able to name these compounds correctly and being able to get from the formula or from the name back to the formula. So a few exceptions, because what would chemistry be without some exceptions to the rules? So we saw our example with carbon monoxide, and we saw that we didn't put anything in front of the carbon, even though there was only one carbon. And so when we have the first element, and there's only one of them, we omit the mono at the beginning. So we just say carbon monoxide. Now notice the second element, there's only one of that, but we can never omit it for the second element. Only for the first element may the prefix mono be omitted, and that's the only prefix that we can omit or leave out of the name. Now for oxides, what we find is that when we name an oxide, if we have a prefix ending in A, like tetra, so like the example we saw with dinitrogen tetroxide, we don't want to have this AO combination, which is a little odd, and so we actually say tetroxide, so we drop that A in there. So that's just a minor issue, but it is an issue when you're looking at, say, spelling and online homework. You do need to pay attention to those types of things. So a prefix ending in A before an O, we're going to drop that. So no prefix if the first element only is only one of those. In any other case, we're always going to have a prefix for both of our atoms, so we know exactly how many of each type of atom are in that particular compound. So let's look at some more examples. We have S, which is sulfur. Okay. And there's only one sulfur, so we don't need to put mono in front of it. We can say sulfur. We have 3 oxygens, so that will become oxide, and we need the prefix which represents 3, so we have trioxide. So now we can see we have sulfur, we have one of those, and 3 oxygens. So we have no prefix here. That tells us we only have 1 sulfur, and we have a prefix of tri in front of oxide telling us we have 3 oxygens. The order in which they are written in the formula is the same order in which their name is written. Now we go on to the next example, which actually gives us the name, and we need to get to the formula. We have carbon tetrachloride. So I have my carbon. I know that's going to come first in the formula because it's first in the name. Notice there's no prefix in front of carbon, so that tells me I only have 1 of those carbons. And then I get to chloride, so I know that was Cl, and it has the prefix tetra, which tells me I'm going to have 4 chlorine. So our formula for that compound is going to be CCl4. Now, let's look at this last one. We have P4S10. First, we want to write out what our element is, our first element is. So we have phosphorus. Now we have 4 phosphorus in this particular compound, and so we need to think about what that prefix is. What is the prefix that means 4? So tetra is the prefix we want, so we have tetra phosphorus. Notice that there's not a space between the prefix and the name. It kind of looks like it here because I was misjudged my spacing there, but normally we don't have a space there. And then we have 10 sulfur ions, so we have our sulfur. Now again, we need to know the prefix that means 10. So what prefix do we know that means 10? So deca means 10, and so what we see is we have deca sulfur, but we don't want to leave it as sulfur. What we actually want to do is change the ending to IDE. Now when we're dealing with covalent compounds, notice that we're never dealing with polyatomic ions. We're just dealing with the elements. So let's rewrite this so it's a little bit easier to read. So we have tetra phosphorus, deca sulfide. So no space between the prefix and the element, okay, but a space here between the 2 element names.